Let's look at another sports-related example. Here we have for each NBA team for the 2012-2013 season, in the center column we have win-loss percentage. In the first column we have their free throw percentage, and in the last column we have rebound percentage. Free throw percentage, of course, is an offensive statistic, and rebound percentage is a defensive statistic. So let's compare each of these with the win-loss percentage and see which is more closely related, or at least which has a larger correlation coefficient. So we're going to check to see what the strength of the relationship is when we take free throw percentage as the independent variable and win-loss percentage as the dependent variable. So we'll click Stat, Regression, Simple Linear, X variable, free throw percentage. We expect that to drive win-loss percentage, and click Compute. And we see that our correlation coefficient is 0.079. So not very close at all. So we see then that for at least the 2012-2013 season, taking only these two variables into account, we don't see a very close correlation at all. Looking at the scatter plot, we see a lot of deviation from the best fitted line. Now let's look at the defensive statistic that we've chosen, rebound percentage and win-loss percentage. So let's click Stat, Regression, Simple Linear. We'll take rebound percentage as our independent variable and win-loss percentage as our dependent variable. Click Compute, and we see that we have a much stronger correlation between these two variables, 0.429 if we round to 3 decimal places. And if we look at the scatter plot, we still see quite a bit of deviation from this line. But this line has a greater slope. The slope of this line is not nearly as close to 0 as the other line. So looking at only the correlation between free throw percentage and win-loss percentage, and then rebound percentage and win-loss percentage, we see that the defensive statistic, rebound percentage, that we've chosen is much more closely related than the offensive statistic.